all divided by 7. And it wants you to take the derivative. How about before I take the derivative, I do something like this? Ferris is like, yeah. Hang on, Iman. How about I do this? I just move that 7 out in front for this first term, and then I give this second term something that looks like that. Can I do that?
Yeah.
Now, does it look like something you can tackle? Sure does. What's D out, guys, on this term? So Z prime is going to be what?
5/7.
5/7 junk. To what power?
4.
Good. Times the derivative of the junk, which is?
3.
Good. Now, what's the derivative of this term? Done. How many of you way overthought this one?
Wait, how come the answer is different in the back of the book?
It just recombined stuff.
Oh, okay.
What's 3 times 5?
Oh, 15.
And you still have a denominator of 7 over the whole thing,
Oh.
so,
Okay.
yep.
That's what. Going on thing.
But I told you not to.
I know, I just don't listen.
Yeah, but now you do.
Now I do.
All right, so that was 21. 27. This was this x squared minus 3x plus 3 quantity cubed at 2 comma 1?
27?
Yeah. Or did you guys have,
Oh, I'm at 29, I'm sorry.
you meant 29?
No, wait. Yeah, 27.
Is it x squared minus 3x plus 3 quantity cubed at 2 comma 1? X 3, x 3.
Yeah, every other one. Yeah.
Quantity cubed
You went up to 29.
at 2 comma 1. Okay.
Would we have to do 27 if it's every other one?
Oh, did I do an extra one?
Yeah,
Alright.
that's
Don't
okay.
do
I'm
it.
gonna
We
do
can
it.
still learn. but
Mhm,
I just-
I'm gonna do it. Yeah, I'm gonna do it.
As
This
you
is,
were.
thank you, Brian.
You were so.
You guys are sassy today. So it wants us to find the equation of the tangent line. So really it's asking for this, right? Well, we have our y. That's what? 1. We have our x. That's what?
2.
And where do we go to get m?
Derivative.
Yeah, so this is y. We get the derivative from y prime at 1, or sorry, 2. 2, right? So how do I take the derivative?
Yeah, the outside.
Is it 27 or 20? Like the work problem?
It's because everyone did 29, that's why you're confused.
Well, everyone's working out of different additions, so who asked for 27?
It's 25.
Fucking hell.
But no, like the problem is the same. I just said the wrong one.
Which edition are you working out of?
Well,
Okay.
It's
I think I'm
25.
on the 11th edition, yeah.
But it's the
So
same
our numbers
thing.
are slightly different, same thing, same process. If you're struggling, come find me. What's the derivative, guys?
3 junk.
What's my junk?
X squared.
Square minus 3x plus 3.
To what power?
2.
What's the derivative of the junk?
2x minus 3.
Mm-hmm. Okay, so now all we need is y prime at 2 to get m. So
Yeah. We just put in.
I'm gonna whip through that really quick. Let's see, that's 4 minus 6 is -2, plus 3 is 1, 1 squared is 1, times 3 is 3. So this all equals 3. 2 times 2 is 4, minus 3 equals 1. 3 times 1 equals 3.
Okay.
I'm bored. Do we have everything we need? Yeah. So now we have 1 equals 3 times 2 plus b. 1 equals 6 plus b. What does b equal? Yeah, b equals -5 for this one. It's the exact same process, guys. So now we have y equals 3x minus 5, and that's the answer for this problem. What's the hardest part of these for you? Yeah.
I was just gonna say, I'm really sorry if this is on your handout, because I'm getting there, but the y equals mx plus b, how come y prime, and then, like, you put 2 in, obviously, but how come y prime to the whatever is, m? Like, how do you know
Because
that?
MS slope.
Plug an x, Caitlin, if you plug an x into a function, what do you get out?
Or y?
And if you plug an x into a derivative, what do you get out?
Slope. Okay, gotcha.
Slope is just m.
Sorry.
No, it's okay. That's what I'm here for. I'm here to remind you guys. And that is why I write it up every flippin' class, is because somebody will forget it. So don't laugh, because next time it'll be you. Haha. All right. That's those two. What about 39? Who asked for 39? Which one is 39 for you?
Y equals 32 parentheses 3p plus 1 to the negative 2 plus. And p is greater than or equal to. I have.
Oh, it's your pricing and sales problem?
Yeah.
Groovy. Okay. So, y equals 32, 3p plus 1 to the -2/5, and p has to be greater than or equal to 0. Oh no, just greater than 0. I see. Okay, so you can't set a price equal to 0. That's what it's telling us. It has to, you have to sell it for something. All right. So suppose weekly sales volume in thousands of dollars sold depends on the price per unit in dollars of the product according to. So Y is your weekly sales volume, and P is your price per unit. And your sales volume is in thousands of units sold. So Y is in thousands. That's useful. What's the rate of change in sales volume when the price is $21? What does it want us to do, guys? Find the derivative and do what to it?
Plug 21.
Plug in 21. And what does that tell us? If we go from price of $21 to the price of $22, what is that going to do to our sales? What do you guys think? What's your gut? Not you.
Was I right?
We'll get there. Think about this like a consumer, guys. When the prices go up, what does your desire to buy it do? It goes down. Here it is. So yes. So let's find it. What's y prime? -64/5. Junk.
-7.
Good. -2 minus 5 equals -7. What's my derivative of the inside?
3.
Plug and chug, people, on board. Don't forget your answer is in thousands. So as price goes from $21 to $22, your sales will drop by so much. There's your negative sign to prove it. So your gut told you that your sales will go down, and now you can prove it using math, right? How do you feel? Decent? Bueno? Wetter? Not quite. You're not blondie.
What?
Gringo?
Boy, gringo.
So gringo. That's hilarious.
That's funny when, one of my friends got back from, a mission in, Argentina,
Negative.
Uh-huh.
and he's, extremely, white, but now he speaks,
Argentinian
Yep.
Spanish,
Yep.
which is
So,
its
I
own
guess
thing.
you just run.
Yeah, it's very.
Ask him if he misses Choripan.
Or,
Ask him if he misses Choripan. Just ask him. Just ask him. Trust me.
he also speaks,
But it's
Portuguese.
special kind of chorizo.
Yeah.
Oh my dear
What is
God,
it?
it's good. Their chorizo is like our brats, but they're slightly different in texture. They're not like chorizo that we have here, which is spicier. It's not as spicy. Grill it over embers on the side of the road. Drop it into a newly baked roll. It's heaven. We just got back. So I'm like excited that your friend went to Argentina. Ask him if he misses choripan. Just ask him. Okay, where the hell were we? 41. Your 41 was my pricing and sales. Is that what you guys wanted, was the pricing and sales? Okay. Killed two birds with one stone. Hot damn. Okay, let's get moving, guys. Today, we're doing 2 sections for the price of 1. Woohoo! Indeed. 2 sections for the price of 1. Yeah. Okay. You guys should be pretty comfortable with D out DN right now, yeah? Okay. So, just be blue. Juicy. Let's go. Okay. What if I give you a problem that looks like this?
Is this 9.6?
Nope. 9.7. 9.7. I don't really have a name for it except maybe using multiple techniques. So I guess before we get started with this, which will be like to the 8th power for giggles, here's what we know so far. If y is some function to a power or some x to a power, then its derivative is going to be a and x to the n minus 1. That's the shortcut. And then we have the product and quotient rule. Y equals u times v, so y prime equals u prime v plus u v prime. So this is all review over here, guys. If we have a quotient, then we use the quotient rule to take the derivative. And the last thing we learned was d out dn. So if we have some function to a power, not an x to a power, but a function to a power, then its derivative is going to be nu to the n minus 1 times u prime. That's d out dn. So here's the derivative of the outside. Here's the derivative of the inside. And we multiply those.
Are those all the formulas we learned?
Yep, that's everything so far. Yep. So now we're going to combine those techniques into nested functions. So much fun. Let's start with the outside. Is this a product, quotient, power, or straight derivative? What I like to call the shortcut. a straight derivative where you can just hop right into taking derivatives of terms.
It's a power.
Oh, it's a quotient, all right, but the outside layer is a what?
Power.
It's a power, okay? So what I say when I say globally is I need an outermost layer. Outermost layer is power. So the rule for power is d out dn, right? D out dn. So that's what we're going to use for the outermost layer. But once we peel that outermost layer to do dn, what do we have left? We have a what? Quotient. So locally, and that's the innermost layer, is a quotient. So when we go to take d out dn, when we get to dn, we're going to do u prime v minus u v prime over v squared. You guys with me? You ready to peel? Yeah. What do you guys think? What's the derivative of the outside? Same process. 8 junk. Because you only touch one layer at a time, right? Can't touch the junk until you peel the outside layer off. So 8 junk to the 7. That's d out. What's dn? Yeah. And so the quotient rule is u prime, get ready guys, times v minus u times v prime over v squared. Oh, it's okay. I heard that. I'll let you guys stare at that for a second. The math itself isn't complicated. The hardest part is remembering where you are in the process, which is why it's useful to determine what is what before you get started. Okay? So I will label my u and my v inside. To color coordinate. These make me so happy. You will have these on the test. What? That's it. Yeah. Oh, okay. Okay. I don't want you to simplify that. Why on earth would you simplify that? Because that's just that's a process of sadomasochism. Like, why on earth would I be sadistic enough to assign that to you? I wouldn't. So, not gonna make you simplify it, but I am gonna make you do something like this, so get ready.
Will they on the final?
What?
Will they on the final?
Oh, they'll be on the final. They'll be on test 1 as
But
well.
will they make you simplify on the final? Because you said that the administration writes half of it.
They won't make you simplify it. They write the application problems. I write the pure math. Any questions on this one?
But you said on the test we don't have to explain the.
Just get to this point. Yep.
No, I mean on the test where they write all the real world problems.
Mhm.
We don't have to explain it. You said something about like we don't have to explain.
Oh no, you still have to explain them. You don't have to simplify them. You have to explain them. In an application problem, simply giving me a number is pointless. You have to tell me what it means.
Okay.
So always always be able to interpret your application problems. Always, always. Okay? Any questions on this problem? Let's move
Not
on.
erase it yet.
I won't. How about this? Globally, what is this?
Product.
Raise your hand if you think it's power. Raise your hand if you think it's a product. Raise your hand if you think it's a quotient. Raise your hand if you think it might be a straight derivative. Products have it.
Product?
This is a product. Globally, we have U and V. You guys with me?
Yeah.
Locally, on U, what do we have? Now we have a power. So locally on U, power rule. So when we go to take U prime, so U prime is going to be some D out dn, isn't it? So what I'm doing is I'm laying the ground rules for what I'm doing here. So globally, I have a product. And the product is determined by U prime V plus U V prime. So let's determine all of our bits. What's U? Don't overthink it, guys. U is the first function. What is it? That. What's V?
The second part of that.
Yeah, 2x minus 8x cubed. What's U prime gonna be? Yeah. 5 junk to the 4th times nice. So that's where D out dn appears. And what's V prime? Just for giggles, because we need it. What the hell happens out in there? All hell breaking loose outside. Not really. This morning was fun though, because we got evacuated out of the science building.
Really?
Yeah. Why? There's some gas leak in the basement, which, you know, makes everyone excited. So mid-class, not my class, it was before my classes, but mid-class, everyone's just like piling out. Somebody's running through the halls. This is not a drill! Get out! Okay. What's my derivative, guys? Let's put all the pieces together. Globally, it was a product, so we're gonna use the product rule. Don't be afraid. We have all the parts. Tell me what to write.
U prime, so 4x squared.
Yup. That's my U prime times V. Whoops. Which was 2x minus 8x cubed. Plus U, which was 4x squared plus 3x to the 5th, times V prime. 2 minus 24x squared. So once again, let me label all my bits. So here's D out dn. Okay. That also happens to be U prime. Here's V plus U times V prime.
What's the plus 3 on the end of U prime? Where does that come from?
Right here. So when we're doing the derivative
Oh.
of the outside, this is where that first set comes from, and then the derivative of the inside becomes 8x plus 3.
Okay.
That's okay. It's all good.
I just figured that out, like, a couple seconds.
Totally fine. Actually, let me drop this for you guys, okay? that a little easier to see. And while I'm at it, just pull this all out of the way, which is embarrassingly hard. It's not working. I'm just not gonna pull it because computer, there is a lot down there.
Yeah, all the ones are off. You're okay.
And if I just pull this out now, everyone can see, right? Is that better? Okay, sorry guys. Okay, I'm gonna erase the first one now. What's the hardest part?
Writing it all down.
Yeah. It's not the derivative itself, it's getting it all in there. So I'm literally gonna be checking it off as I go on a test. If I give you a problem like this, I'm gonna be checking for all these parts. Check, 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 check. Make sure every little bit is there.
We don't have to write globally and locally. correct?
No, this is just so that you can start to see what's going on.
Okay, cool.
So figure out your own.
Are they gonna
Excuse
give
me.
us application jobs where I pull up something about that?
Oh, you know, possibly.
Okay, wait, another question for you.
Another answer for you.
Does it matter which one we do first?
What do you mean?
So like, say you saw like the product in the power rule, would it matter if you did the power rule first? Would that just mess everything up?
Well, it comes in its own time. Okay, you don't employ the power rule in this case until you're doing the derivative of your first function. So it depends on how you decide to tackle it. If you see this, you know you're gonna eventually have a power because you know the function to a power, that's a power rule. Okay? But that's only one part of the function. If this were not here, but instead were here,
Then you do the.
then it would be the power rule on the outside and the product on the inside. Does that make sense?
Yes.
Do you see how that changes it?
Yes.
Okay, good.
We're gonna do a problem like that?
Yep. We sure are.
Can you just quickly re-explain globally and locally?
Yeah.
Like what you're doing?
Absolutely. So I'm looking at this holistically. I'm looking at the forest first. Then I'm gonna start looking at the trees. So forest-wise,
Meaning the two things in front.
meaning the two things makes a product, right? Now you start to get into the weeds. Once you define your two things, you see that one of them has a power on it. That's a local power. It's not a power that applies to the entire thing. It's a power that applies to a little part of it. So,
So you first look at the whole thing.
The forest.
And then figure out if it's like a product or whatever else.
exactly.
And then that's gonna be your end equation, U1B plus UB1.
Exactly.
And then you start breaking it down.
Mhm.
That's the difference.
Yep, so essentially, you're gonna have three different choices here, product, quotient, or power. And you're gonna start to recognize them. So what I'm gonna do now is I'm gonna throw up a few on the board and you're gonna tell me what they are.
What is that first,
This,
yeah, so like I know there's product, there's quotient, and there's power, but what's the top one?
the shortcut. The basic derivative that we've been using.
Oh, just
So,
basic.
yeah, so like 3x squared becomes 6x.
Okay.
Okay,
How many application problems are there?
enough,
How many questions are there?
5 to 8. Multiple part problems. Okay. Yes.
My biggest concern with the test, like how are we gonna know which problem goes with which section? Is it just go like?
Practice. Doing your homework, really. Come visit me when you struggle. That's the biggie right there. Reaching out when you're struggling.
You're gonna have a section that's gonna like explain how you want to solve it, right? Like each section will be labeled like.
No.
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 It's just gonna be like a list of.
Take a derivative and tell me how you do it. Show me your work.
You're gonna give us the answers on the test.
I
right?
really think you guys should worry more about learning the material than worrying about how the test is manufactured. Let's move on. Okay, so f of x. Product, quotient, or power?
Power?
Uh,
It's a power.
It's a quotient. On the inside or the outside?
On the inside.
On the inside, so locally it's a quotient. Globally it's a what?
Power.
Let's rewrite it. Now what is it? Product, quotient, or power?
Power.
It's a power. So what's the derivative?
1/2.
D out dn. Power is d out dn.
1/2.
1/2. We'll talk you through this, guys. Junk. You know how to do this.
Negative 1/2.
Negative 1/2. That's d out. Now let's tackle dn, which is once you peel the outside off. So just for giggles, I'm going to peel the outside off. There we go. Because derivative of the outside is done, so we've peeled. What's the derivative of the inside now? U prime times v minus u times v prime over v squared. Shut my parentheses, I'm done. And I'll rewrite that function so that it's complete again. How do you guys feel? Don't worry, we'll see more.
And what was it locally?
Locally, it was a internal functions, top over bottom is a quotient. Very nice. So globally, this is a power, locally, it's a quotient. Okay? What about this one? Product, quotient, power, globally. Quotient, it's globally a quotient. So what defines our overall behavior? The quotient rule. So we're gonna do u prime v minus uv prime over v squared, right? So because we have to identify all those bits, we're gonna start labeling them, right? So what's my u? Good, and what's my v? And what is the bottom?
The power.
Yeah. And what is my power? Careful.
Did that 1/3?
Yeah, it'll be 1/3. Wrap your internal function and give it a power of 1. So this becomes a 1/3 out here. You guys with me? How many of you like products more than quotients? Groovy. Make it a product. Don't worry, you can parenthesize that 4x so that it's a little clearer. So if you want to make it a quotient, keep it a quotient. If you want to make it a product, make it a product. You totally can. How do you feel? They'll be the same. So which one do you want to do, the product? The answers will be the same. They'll look different, but they're the same, just in different form. They'll have all the same elements, just in different places. So what's my derivative, guys? Let's do the product rule just for giggles. So h prime is going to be, what's my u prime? What's my v? Oops, x minus, apologies guys, x minus 6x squared to the negative 1/3. That's u prime v plus, what's my u? And what's my v prime?
Negative 1 minus.
Junk
Oh yeah.
to the what power? Negative 1 minus 3, guys. Negative 4/3. And what's the derivative of the inside?
Negative 12x.
It's a derivative of x. Nice. So let me label all your bits. Here's u prime, here's v, here's u. And all of this is v prime because v used d out times dn.
Nice. Oh.
It ain't sexy, guys, but it's an answer. There is no math in here you cannot do. All you have to do is pay attention to the outermost layer versus the innermost layer and proceed accordingly, okay? Now, this would have made you run for the hills if I'd thrown it at you, take one. Brian, did you put your hand up? Oh. Questions?
Is this all we're gonna be, is this just for test, like, I know that it's just for test one, but like, is this all we're doing all of it?
No.
Just curious.
Oh, no, there's so much more coming.
Oh, yeah.
Today, though, so I really want to take 5 minutes, and I want you guys to work through a couple of these problems on the handout. Yeah, there's a handout. You two have it. You three have it? You don't have it yet. Hi, sunshine. So 2, 5. Hey, Haley. It's Haley, right?
You got it.
Perfect. I'm sorry, you didn't look up and I'm like, shit, I got it. What?
What's your class tomorrow morning doing?
My class tomorrow morning, they are doing chapter 10. They're starting chapter 10. So they start chapter 10 before the test. You guys start it after. Yeah. But no, none of you are going to get tested on chapter 10 for the test. That comes in test 2.
So they just have more on their plate.
So, no, they get the same amount. They just go 1 extra day to do it. That's the nature of having Labor Day off, guys. You have to pay the piper eventually. You learn the same material.
So there can be one class in that.
5, 6, 7, until after the test, and then we'll be that one. That one's good. Okay.
I have a question.
I have an answer.
Yeah, so I think you missed that test. I think the negative 4 over 3 gonna be negative 2 over 3. No, I mean, that one. I'm not sure why that is, no, why that is.
She's talking about the exponent.
Negative 4 over 3.
Why it's negative 4/3?
Yeah, because I think it's negative 2 over 3.
Ah, but see, it wouldn't be negative 2/3 because the squared is only attached to the 6x.
Oh.
So I wrapped it and gave it a full exponent.
Yeah,
So
right.
if you don't have an exponent marrying everything under there, give it 1.
Yeah, so,
Just like when you have square root of x,
yeah, I know
there's a 1
that.
there and a 2 there. So when you have a whole function, x plus
Right.
5,
But-
there'd be a 1 there and a 2 there.
Negative 1/3 minus 1.
Yeah, negative 1/3 4.
Because when you subtract 1 from the exponent,
Gonna be.
Yeah, negative 1 minus 3 is negative 4.
What?
Negative 1 minus 3. Remember I said top minus bottom?
Yeah.
So what's
Oh, yeah,
negative
yeah.
1 minus 3?
Negative 4.
Negative 4. So that's where this comes from.
And this is the formula.
If
It's
I
not
were
to
to
the end
add,
anymore.
that would be positive 2/3.
Oh.
But I'm not adding, I'm subtracting. I always subtract 1 from the exponent. Always, always, always.
I'm confused.
Where'd I lose you, Haley?
Just a second.
Okay, I'll let you stare at it.
Yes.
So on this handout, guys, I really want you to like
So,
flip to the second to
Oh, yeah,
last
right.
page. Yeah,
I got it.
second to last page, and all I want you to do is tell me if it's globally a power quotient or product and where my U and my V are gonna be located, because they're gonna be in there somewhere. You're gonna have either a power and a product or a power and a quotient, one way or another. So you have to tell me where your U and your V are gonna be, if they're global or local, and what your global function is, okay? So on that second to last page, we have 4x to the 5th minus 3x squared all cubed times 3x plus 6. So globally, is that a product, power, or quotient?
Product.
Product. Now, what's your U in this product?
4x.
Minus 3x squared all to the third. And what's your V?
3x plus 6.
3x plus 6. So when you go to take your derivatives, that's what you're going to use. Your U prime and your V prime come from that. Does that make sense? That's why. So you're not solving these, you're just setting them up. Groovy?
yeah, so you're trying to use, right. Figure out what's your U and what's your V.
Oh yeah, that's right. You told me, didn't you?
I did.
Yeah.
So then
And I was like, oh.
what's your U?
What? Yeah, you sure do. Come get an after class.
It's only considered a power, if the power is,
So then
like for all of it, right?
Yeah, it's
So like this is a power.
that's how. That's right.
And then because this three is in parentheses,
Not attached.
yeah, so then this is a product.
What about this one?
Is this derivative only applies to this V? Or is it power
What is that attached to?
Product. Just a product, yeah.
And locally it's a power.
Okay, so then
Is it this side? Only applies to this? So then you just plop.
That's your
So
U.
then this was just the outside, right?
yes, ma'am.
And you're welcome. Sorry.
And then locally it's 8.
Sorry.
Does that make more sense? Yeah, of course, it was definitely confusing. So this
I'll be right here, Brenda.
So with that, with the V squared, so would we just have it, raised to do again?
Exactly.
Cool.
Yep.
So you don't have to.
Brenda?
I'm confused on this guy. Do I have to like convert it to like the 6?
That would be if you went to take the derivative, yeah.
Oh, okay.
So remember, because it's a power, you're doing D out, DN. So D out would be 6 jump 5. And then DN would be the product.
Which is the inside.
Yeah, well, careful. Your U in this case is your 4x.
Oh.
Because globally, this power rule doesn't have. I see what you're saying. This is U and V in the product and quotient mix, not U and V on D out DN. But I see what you're saying. Yes.
Is this correct?
Yeah, absolutely. You're good.
Globally it's a power. Globally it's a product. So then the U would be. Yeah.
Can't wait to go home and forget all of this. We'll bring her back. Two lives.
No, you're good, thank you.
Yeah, I know. I just need to figure out how to tell myself like the application problem. I usually, first of the problem is what we're fine, and then we'll get 5 minutes to your complicated. Is the book teaches it. So this is like, yeah. Yeah, because they want you to simplify them. Right?
Now, it's probably
These are her handouts.
Did you get that shirt?
Online?
Online website.
It's, I just typed in the company name.
Ew, no.
So, yeah, they got a bunch of questions. They're gonna.
Assistance aisle 1 and 2.
I got one like this, I got one with
Where are you at?
jellyfish on it. They're called really cool.
But you're right, it is square.
What'd you do for this class? Oh, you have not?
Product is what she just went over with the,
I know, I'm just like, just going in there, I have to.
So that sometimes will be, just so they'll find all the.
So for powers, yeah, so there is a use local, there's also.
yeah.
So, yeah, ECU and D are actually local.
Is that what you got? Or is that what you're using?
Yeah.
Yeah?
Probably.
But I was that'll be.
So all this is like right on here, right?
We go 6 jump to the, and jump goes inside.
Yeah.
And now you're just outside, like
And globally would be like.
But
You're killing it.
Sounds like you guys are
Okay, so what we outside?
So, once you know your power off, where's your?
That's how I choose one.
Oh, it's just 10.
Yes, that's perfect.
So, do you know how this power is basically the whole thing?
So it's use current plus minus times the other.
No, it's always UV. It's always UV. It's just in the first one, it's U times V. So you would have V. The times in the beginning.
That's just to find out, so, literally just doing it to see what you do, right? So for this one,
So when you go to change the derivative, you go to the outside first. So 6 jump to the left. And then you clean it out, and you're left with the.
Yeah, I got no idea.
Alright. How are my central columns doing?
so this
Line to us.
I didn't lie to you.
You did lie to us.
I didn't lie to you.
The answer.
I swear to God, I never lied to you.
The answer, sister.
So
Oh, really? Well, we'll talk to you about that.
Liar, how could you? How could you?
Am I doing these first?
It's backwards.
Okay, so get rid of that article first. So parentheses right here.
It's good to label.
Good. And then,
Just color coordinate, right?
Exactly.
A different color for each part.
You was my
so local is just
get rid of the radical backwards.
Yeah. Well, like,
Good. So now, regular product portion or power. Good. So perfect. How about
So the 4 goes right here.
yes. So yeah, so this
And that's the U prime, right? And that's the U prime, right?
I'll be back. That's your payment for calling me a liar. Awesome. Now I got it.
So where do we start from? When this is in fall. I can't get it off my head. Thank you.
Front row, how are you guys doing? Are you nailing it?
I have a question.
As an answer.
Okay, so for these guys,
Yeah.
that's identifying just your outside. Like,
Good.
Okay,
Good.
Now when you have to do the U prime and V prime, that's
That's the D out DN stuff. Now you're getting, yes, yes.
okay.
Perfect. So now you have all your parts. Because it's a product, you're just gonna use the product rule to fill in your final answer. Because you have all your parts, just fill them in.
Okay, perfect.
Right?
Yes.
How about you guys? How are you doing? Awesome. Is that right for you? Ah, okay, careful. So this 6 is tied to everything. So globally it's a power, but once we peel that off, now what's our U and our V? So the 6, yeah, so the 6 is tied to everything, so you would peel that off first when you take your derivative.
So 6 doesn't follow anything.
Well, it becomes part of the derivative when you do D out DN, because globally
Is the correct answer
when you get to the end, that's when you do the U prime and V prime, because inside you have a product.
Okay.
Okay, you're right there. Good job, you guys.
Wait, did you ask Brenda what you got? Are you sure about this?
I didn't know that one.
You can't just do that in life. You can't just skip stuff. You know?
Yeah, I can. She's gonna do it up in the board. Probably not.
Are you gonna be like, well, time guys?
No, we still have to do the second part. Yeah.
Whoa. Here come the applications.
Same girl, same.
More than half my grades. I have another year left. That make it two hours. You get like 18 credit hours.
And I will never attempt because
You doing it right now?
that just confuses me even more than it was.
Take up a lot of your time.
So it should be.
I understood. It's literally the same
Yeah, so for that part, yeah, so that'll to the board. And then the second part's so the derivative part. There's like, also, still on the U prime, you gotta make the, there's just
Where? In the morning? I was like,
Here there was a lot of caffeined up.
I agree with you.
All right, you guys.
No one talks unless it's relevant.
Yes.
This stuff that I want.
Really quick, and then I gotta start the next lesson
Okay.
because we have 15 minutes.
This one.
What about it?
What do you do with this exponent? Like, what do we do with it? Do we add it in here or?
You would do, when you take the derivative, you would start by peeling the outside layer, so 6 jump to the 5th, and then you would use your U prime V plus UV prime. Okay, I'll do the last one on the board. Yeah. All right, you guys, I've gotten enough questions about the last problem.
I think I'll do like that.
We've gotten enough questions about the last problem that I want to tackle it. Globally, what is this? It's a power. Locally, what is it? It's a product. So we're going to globally use D out dn. I hope you guys can all hear me. Globally, we're going to do D out dn, but locally, we're going to use U prime V plus UV prime to do dn. So let's start with the derivative. So this is it.
What one to do D out DN too?
Anytime you have a power, it's D out dn.
Ah, okay.
Yeah. What? You're good? Okay. So the derivative starts with D out dn. So let's do D out 6 junk, which does not change, right? You never change the junk. One layer at a time, so 6 junk to the 5th. Now we peel. So imagine this 6 and these outer parentheses are gone. Now we have a U and a V. So what's my dn? We're going to use U prime V plus UV prime to do this. So what's U prime? 4 times V, 3x cubed plus 5, plus U, which is 4x times V prime, which is 9x squared. And I parenthesize that and we're done. So here's the derivative of the outside. Here's the derivative of the inside. And inside dn, we have U prime V plus Q V prime. So if I were to take this all the way out and solve it, this is the set of elements I'm looking for. But I didn't ask you guys to do that. All I wanted you to do was identify that this is a power on the outside, and on the inside, your U is 4x, and your V is 3x cubed plus 5. That's all I was looking for. Does it make sense? I promise I'm not throwing you guys more than you can handle, okay? I know you can handle this. So, no, it's a good assumption, no. I'm working off of 10 years of data.
There you go.
Well, 8 years, really, since I solidified my technique. So, that's 16 semesters.
That long, that's why you get it.
Multiple classes per semester. I got a lot of data on this. I know you guys can handle it. All right, so next section, because we're not done yet.
Wait. For the DN, are you supposed to have a fifth?
What?
Are you supposed to have the 4 times the 3x to the 3rd plus 5 to the 5th?
No,
No?
we did that.
Oh, okay.
When we peeled the outermost layer, this and this completely disappear. And what you're left with is U times V. You're left with the product. Okay? All right. So 9.9. No, at 9.8, that comes with chapter 10. I don't know why the textbook does that, it's stupid. So we're doing 9.8 later. It's easy, it's the second derivative. You guys already know how to take a derivative. I'm not gonna waste your time on that right now. You're just doing it again, that's all. No big deal. Okay. All right. So now, applications.
It disappeared.
9.9.
That was a nice.
You guys are also going to want your handout, the basics of business in the context of this class. So if you don't have it, grab it.
I think I left it on the desk. Or that's what I made up. You. So.
don't even need to look at it again later.
Too early.
And before you guys freak out and take off, I'm gonna go ahead and give you your checklist for the exam. I don't give review problems, Caitlin, remember? I talked about that. Yeah, I'm giving it out right now. 2, 4, 6, 7.
That's what we're gonna do. We're gonna make sure we have all these things on, like, we know how to do it, like, either
Thank you. I'm just gonna use.
Best I can.
You probably will. So she has an extra. Because then we could just like scratch
All right. So applications. And I'll get to the review sheet after we talk about applications for literally 5 minutes. Sorry, guys. But applications. I want you guys to definitely read your basics of business in the context of this class. So in there, I should have a copy myself right here. Yes, okay. So in that, I talk about revenue, cost, profit, marginal revenue, marginal cost, marginal profit, okay? And a lot of this was stuff you didn't really understand at the very beginning, but now we've been doing it for a while. So marginal profit equaling 0, that's the X value or the production value that maximizes your profit. So this is off of the basics of business. So if you want to maximize your profit, what's the process? Take the derivative, right? Set it equal to
0.
Solve for X, and then you get that X value, which is production, not profit, and you shove it back into what thing to get profit out. You plug it into your profit function. If you're asked to find maximum profit, you're going to eventually plug an X into a profit function, aren't you? Yeah. Yeah, you start with the derivative, set it equal to 0, solve for X, plug X back into profit. Okay? How do you maximize revenue? Same procedure. Take the derivative, set it equal to, solve for, plug X back into revenue, and you've got max revenue. Damn, okay. How do you minimize average cost? Because remember, cost itself is not something you can minimize. If you want to minimize cost, you set production equal to 0, and your fixed costs are your minimum costs, right? When production equals 0. What you can minimize is average cost, or cost per unit. So if you want to minimize average cost per unit, what do? Take the, set it equal to, solve for X, plug the X back into your average cost function, and you get your minimum average cost. It's the same procedure, guys. It's the same procedure. So on your application problems, you guys are going to need to know this stuff. You're going to need to know it cold. If I tell you to build a revenue function, you've got to be able to do it. What is revenue? Revenue is what times what? Price times quantity. Okay, so if I give you a price of 400, what's your revenue function going to be? 400x. Very nice. Don't overthink it. Your quantity is always X. Okay, production value is always, always, always X. Unless it's time, but that's a different kind of problem. Okay. Yeah, we're so not going to have time to do this. Okay, so this, on page 2 of the application set, this is the kind of problem you might see on a test. And we're not going to have time to go over it today, so just put a pin in it, and we'll get to it on our review day. Ruby? What? Page 2. Yeah, of your applications handout. So we're not gonna be able to get to it today. So I want you guys to stick a pin in it. And the same thing with the thing on page 4. You guys have gotta be able to read graphs as well. But the thing on page 4 is very similar to page 4 of the basics of business. They look really similar, guys. So what's happening in these is you have some kind of negative profit because cost is higher than revenue in this region. So this is in the basics of business and this is the application set, okay? So this is negative profit because cost is higher than revenue. Where they cross is literally where revenue equals cost, and that's what point, guys? Break even, your money out equals your money in, okay? The further out we go, the bigger the distance between these two lines gets. The place where the distance is largest, that's your maximum profit. You guys with me? Literally the largest distance between revenue and cost when revenue's on top. Always when revenue's on top. You get X max, or the production level that maximizes profit. So if we were to overlay these, you can clearly see that break even is where the profit function crosses the x-axis. You can clearly see that this X max P is the same place where your profit function would be maximized. Okay, where that distance is maximized, that's where your profit function is maximized. So far, so groovy? So definitely read these through, give these a shot, because they go hand in hand. We've had this one several weeks. Now let's talk about the review sheet. I want you guys to go home. Well, I'm going to give you homework, obviously. Do your best with the application problems. I know you guys get shorted a little bit. That's kind of the crap reality of this class. So you guys do get shorted a little bit on time because you're the Monday, Wednesday cohort. But these application problems, everything you need is in this handout. So everything you need to do the application problems today. The review sheet. Why do I not give you guys homework problems or sample problems?
Because it might be different from the test and you will get at it.
Yeah, if you guys get practice problems that are too similar to the test, that's insulting to your intelligence. Seriously. You would substitute numbers and get the right answer. That's embarrassingly bad. It's college. Suck it up. Come visit me if you get stuck. But you gotta do the work. Now, if I give you problems that are too different from the exam, you'll feel cheated, and rightly so. Haven't you guys ever had an instructor who was like, here are your sample problems, and then it's nothing like the exam? Yeah, don't you hate that?
Your best friend does the review sample problem.
Yeah, that's her class.
No.
We're in my class now. We're in my class now. So what I promise you guys is when you ask me problems, ask me to work problems or make up a problem, I can do that. During the review, that's what that time is for, is for me to go over things that you might have an issue with. And if it is not on this handout, it is not on the test. So for example, there's nothing about solving those f of x plus h minus f of x over h problems.
Thank you.
There's nothing, so you don't need to know that for the test. What you do need to know is what it means, and that is on the review sheet. Okay? You guys see the difference? Okay. Here's your homework. You're in my class now. Oh, that sounded mean, didn't it?
Yeah, my feeling.
Well, you're snarky, so I'm just responding. Snark for snark. Snark for snark. You guys are fun. So in 9.7, I would really like you guys to do, I don't even remember what I gave them. Do you remember, Brenda? I have no flipping clue what I gave you guys. Brenda's gonna give you your homework today.
If I
She
can
rocks.
find it.
15,
I don't know.
21, and 27.
15, 21, and 27 on 9.7?
Yeah.
That sounds about right. 15, 21, and 27. Groovy. And then 9.9. That's fine, honey, you don't have to dig it out. I've got them here. I would like you guys to please do,
1 through 7
yeah, 1 through 7 on. Yeah,
and 27, you said.
and then 27?
Yeah,
Okay,
that's for 9.9.
that's good. Thanks, chickens. I will see you bright and shiny on Wednesday. Come with questions.